Hello and good morning. Today I'm going to solve my first Leetcode daily problem, and why I solve it, I'll try to explain it. So let's get a few things uh, turn on Windows plus R. Okay. So I'll try to explain most of my illustrations through Paint, and uh, for any other things, I will probably use a I will use a text file. So let's just for yes, yes. So um, so let's go to lead code and just start. So Google. Okay. So let's head over to lead code and let's have a look as to what kind of problem we are going to get today. So mm, okay. Uh, then how do we access the problem of the day? So there is a problem set. Okay. I don't think it is here. So interview. How do you get the problem of the day? Let me just Google lead code daily. Oops, daily. Uh, explore it. It says explore. I don't see anything here. Just system design. Uh, how to find lead code daily, or where to access lead code daily from. You can access the daily challenge problem by using the calendar on the problems page. Okay, so problems. Uh, yeah, all right. I think we found our problem. Okay, so I see this is an easy problem, and it says you're given an array of string words and a string prefix. Return the number of strings in word that contain pref as a prefix. A prefix of a string is any. Okay. Hmm. Okay. So the problem is basically asking you have a bunch of words like strings in an array, and they give you a word called pref. So they want you to check uh, the number of strings in the array that have this word pref uh, as a prefix. A prefix is basically a word. Uh, uh, a prefix is a word that matches the very from the very first character. Like a prefix is basically a sub. Okay, so a prefix is a word uh, which is what your uh, whole word starts with. Basically, to say, so let's say if 80 is a prefix and 80 is the word pref, and you want to check if it's a prefix. So from the very beginning of the word attention, you will start matching letter by letter, and if you can match it for the whole length of the prefix, then that's basically a prefix. So to clarify more, um, let's use a text box. Where is the text box? Okay. So let's say you have this word um, uh, attention and attention. So is so how to check for a prefix? So so all the all the words that start from the first letter of this of the word attention. So all the words that start from A and match throughout the length of the string is a prefix. So here the prefixes are A, obviously, AT, because AT, the first letter A is matching and the second letter T is also matching in the string attention and ATT. So yeah, so on. And the full word itself is also a prefix. Oh, well. So like the whole word itself is also a prefix. Okay. So okay. So the whole word attention itself is also a prefix. So now let's get back to the problem. So the problem asks we have to check if the given word pref is a prefix of the strings. If there are any such words, we will count them and we'll return that. So there are actually several ways to solve a problem like this. And the simplest way to go about this problem is just to compare the strings. Basically, just compare character by character with each string. So to illustrate it as to how we will do that process. So let me use my text file. So let's say uh, the word we have is, say the characters of the word are S1, S2, S3, S4, S5. Let me make the letters small for ease. Okay, so S1, S2, S3, and let me space them S3, S4, and S5. So this is the actual string. Let's say our prefix is P1, P2, P3, P4. Pref. So how will we actually check compare? So how comparison works? So the simplest way we will compare is we'll check if S1 equal to P1. We'll check if S2 equal to P2, S3 equal to P3, and S4 equal to P4. So if all these equalities hold, then pref is a prefix of our actual string. So we could write, to simplify this notation, we could say Si equal to Pi for I in index 0 to uh, length of of pref. So here I'm using the computer notation. Basically, in computer, the first index is the index 0, And this square bracket is a mathematical notation which means exactly from 0, and this open bracket means the curve parenthesis bracket means 1 less than the value. So this actually means same as 0 to length of ref minus 1. So we need to check that every character of S and P match for all the indexes starting from 0 up to the length of the prefix string minus 1. And we can code it quite easily. It's like this condition itself is the whole solution. So let's talk about what's going to be the complexity for the solution, because in any interview or in general in any discussion around algorithms and data structure, we we have to consider the time complexity, and we also consider memory. But here in this problem, memory is not that big of a concern, because every comparison is quite simple, and we are not using any additional storage or additional data structure. So it's fair to assume that the memory complexity is roughly about the same as time complexity. So let's calculate the time complexity. So here the time complexity is, let's say we have n words. Okay, n words. We have n words, and uh, they might have, say, L1, L2, L3, and so on, ln lengths. So these are the lengths of all the n words, and our ref word ref, say it has lm length. So we have to when will we first and foremost will compare this ref with every word, so it's guaranteed that we are at least going to check we'll at least check through n times. We'll at least do this comparison n times. That is quite obvious. But what what is the cost incurred com, per word comparison? So in the worst case, in the worst case, we have to check every character of prep. So worst case, every comparison is going to take LM character comparisons, and since we'll be checking for every word, which is so, and we do this n times, so our complexity is big of n into ln in the worst case. Now let's check the constraints for the problem. So the constraints for this problem state that uh, we have 100 words in the worst case. The Okay, so there was some problem with the encoding, and the previous part is I checked it. It's more or less okay. In the part where I explained through the text file, it's a little laggy, but it's somewhat manageable. The problem Today's problem is not so difficult, so I'll leave it as it is, and I'll combine this part with the previous one. And I'm hoping I reduce the FPS, and I'm hoping there won't be any more overloads. Let me just close unnecessary bars, I guess, in the taskbar. um, and let me just save this. I don't think I need to use this anymore for this problem. So let me just save it. Okay. So let's go and finish this. I'll start with the code. Um, okay. So all right. So we have this. I'll I'll be coding in C++ only, most likely. If I ever have the time to consider some other language, then it most likely will be Python. But the odds are mostly that I'll be only doing it in C++. Okay, so let's uh, finish the code and check. Okay, I want to check one thing real quick about my summations. Just let me have a look. 4 days ago. Okay. Okay. All right. So let's get back to the problem. So mm, let's just have a look at the. Okay, I think the encoder is doing just fine. All right. So let's go. So first and foremost, we have our words and we have our prefixes. So for this particular problem, I didn't sketch down how we'll break through our implementation. This problem is not too hard to implement, so I'll just quickly finish the code here without any additional uh, explanation spent on implementation details. Okay, so now let's go with the solution. So we have our word prefix. So I'll first take int, let's say num words. I will just use normal variable names and I'll explain what these mean. Or maybe let's just use normal. So this is self-explanatory. This is number of words. So I'm just using words.size for this, and len is basically the length of the prefix word. It's simply ref.length. Now we have an answer which will count how many words match with this prefix. So now I'll go point I equal to 0 and I less than I plus plus. We are iterating through every word, and now a little slide. Um, Basically, we can do the comparison through the whole length of the string, but one detail that I did not mention, that is, it is not necessary. I mean, it's a very trivial condition, but it is not necessary that word and ref will have equal length. So we need to handle that simple case, and to handle that case all we have to do is basically go up to just uh, compare up to the minimum length of either words I or well, actually, to be fair, let's not do this. This is we'll have to then write additional pointless code to handle the check. So let's just go all the way up to pref, preflen a plus plus, and let's do the the trivial case check beforehand. So the check is simple. If words I dot length is less than ref, then it goes without saying that the prefix cannot match because the word is itself smaller than the prefix. And here I was making a silly mistake. We'll just continue in this case. Hello. Home and end buttons not working. Okay. Now just quick check if the encoder is overloaded, and it seems like it is not overloaded. That's cool. I will just put a momentary pause, and it will not be, you won't be able to understand it in the video, but like let me just yeah, so like I'm also learning about OBS as I'm doing these recordings. Okay, so as I said, if the word length is smaller than our prefix, then there is no point in comparing. Now we will just check if words I j not equal to, if it's not equal, then let's have a boolean, because we need to ensure that the check actually works. So we'll do boolean flag true. This means the prefix indeed match for the whole length from the beginning of the word. So if it's not equal to our ref the prefix, then we simply do flag equal to false, and we will immediately break it because there is no point in checking any further. And if flag, that is if it is true, then we simply increment our answer by 1. And with this our code is done. Now we just return the answer. So one quick quick look through what we did. So we basically first took the number of words in this variable numbers, and yeah, I have this habit of using n, so I wrote n again, and we took the length of the prefix word. If the word length was smaller than our prefix, then by prefix I mean pref, then we simply skipped. Otherwise we checked by character, and we ensured that our prefix actually matches completely through this boolean flag variable, and then we accordingly incremented our answer and returned it. So let's now check it on the trivial test cases. Run. Let's hope there are no errors in this simple code. Okay, there is no error. Now let's try submitting this solution. How do you, okay. Okay, so it's getting submitted. So let's see. Okay, so it says submitted, and the runtime is 0 millisecond. That's crazy. And the memory is 13.14 MB. So, well, I said that the memory complexity is roughly going to be the same as time complexity. As you can see, in terms of memory, we did not really use any additional data structure as such, just 3 integer variables and few comparisons. So there is no extra additional as such extra memory that we used. But still, it's being run over, like these 3 integer variables still do use some memory, and it's being run over like some some several 95 test cases. So yeah, that will, if you divide 13 MB by 95, you can already see that the amount of memory used is actually very very small. Yeah. So with this we are done with the code, and okay, it's still fine. The recording is okay. So a few things that we can discuss real quick. Okay, so first let's have a look at the tags, the topics. So it says array string string matching, which is true, and the company is okay. This is raw for premium feature. There is hint, and obviously there is similar questions. So with this, we're done with the first day of Leetcode daily. So what I want to discuss is that in this problem, there was actually better ways to solve this problem, and the better way to solve this problem is basically, well, actually, uh, really speaking, maybe there is no better way than this comparison. Like we have to at least compare word by word with prefix. So yeah, there really is no better way than this to solve the problem, because our solution is already not dependent on the length of the word, like the input. It's not dependent on the input length, yeah, like the length of the words in the input. It's only dependent on the prefix. But usually, like in such string matching problems where prefix is involved, sometimes we can see some data structures like try being used, or occasionally you will see some specific string algorithms used. But let's keep it for when it actually comes in our daily, and not discuss about it today. So here I'll end this recording, and I'll try to merge the first video with the second one, which should be possible. If it's not possible, actually it might not be possible because the frame, the FPS is different across the videos. If it's not possible, I'll try to like put two separate videos and put a link in the description so that you can follow it through that link to the second part and watch it completely, or I'll try to combine. Anyways, so this is day one of Leetcode. Thank you for watching.